Hello, everybody. My name is Phil Undercuffler, Director of Product Management and Strategy with OutBack Power Technologies, and I'm here to introduce our new Radian Series GS8048 inverter charger. OutBack Power has been long known in the industry for making reliable quality products, some of the best products out on the market, and also supporting those products with some great support. We've always shown that we've got your back. We know what it's like to be in the field and have challenging problems and challenging customers and needing a higher level of support. I think you'd agree. We've always stepped up and made sure we had your back. But it's been a little while since we've had some new products on the market, and we're really excited to be here today introducing some of the products we've been working on. And of that, the OutBack is proud to announce our new Radian Series GS8048 inverter charger for grid interactive and standalone applications. And really, this is pretty exciting for us. It's our first round up brand new inverter in many a year, and gave us the opportunity to really step back and say, what should an inverter be? What should an inverter do? What do our customers need out of an OutBack product? We have a lot of history and a lot of track record with our FX product. People know it very well, think very highly of it, but we know that there were certain things that we've always felt it could do better. Some challenges we know people have had that we think that we could make easier to have a successful implementation of a renewable energy system. And we really wanted to address those issues with our new product. So starting with a fresh sheet of paper gave us the opportunity to really say, what should an inverter be? And if we really summarized it on one sheet, one line, it would be how can we make it simpler to successfully install and design and implement a power system, to make it easier for anyone to successfully install and design battery-based systems for both grid interactive and standalone applications. Now, why do I say simpler? Why is that important? What I had seen in my experience as both an installer and an integrator was that up to now, everything's been custom. And we know as OutBack that we're part of the problem there. We make a great universal modular inverter that does everything. Unfortunately, it requires an adapter to do just about anything. We make one set of sheet metal for a single inverter. It's got a wiring diagram and a parts list and even a bypass kit for a single inverter. If you want to do a two-inverter system, we have a different set of sheet metal and a different parts list and a different bypass and a different wiring diagram. If you want to do 3 or 4 inverters, it's, again, a totally different set of sheet metal, parts list, wiring diagram. Everything's different, and that makes it extremely difficult to scale up, to do larger systems, to know what it's going to take. Either hard for distribution to have the right products in their mix, to have the right products on your shelf, to have it on the right truck, to remember to even quote it on the system. What we were finding is more and more people were shying away from that complexity. Even if an installer knew how to do systems very well, if they did a 2-inverter system, they could almost recite the parts list from memory. When the first time presented with a 4-inverter system, they had to start over again. First time they were presented with a 6-inverter system, they had to start over again. And we were seeing, therefore, more and more people were stepping away from battery-based, leaving it to other people, saying only those specialists were doing battery-based systems, talking customers out of those applications. We at OutBack see a lot of growth and a lot of future in systems with energy storage. What we haven't had is a product that makes it easy to provide that solution. So our goal for the Radian series was simple. how can we make the design and installation of battery-based systems of any size just as easy as string inverters? Now, that's a pretty audacious goal. And to be honest, there's some things that we can't polish out. There will always be, in a battery-based systems, a protected load panel and a main load panel. And the installer will have to choose certain circuits and move them over. And they will have to size the system for those circuits. They'll have to size the battery bank. Those are things that you really, there's only so much you can do to dumb that down. But everything in between we viewed as an opportunity to simplify and standardize and make repeatable. Some of the things that we did was, first, how can one box do many jobs? Well, having grid interactive and standalone in the same inverter, in the same part, instead of being really what is a software issue, how can we build it all into one device and let you choose what job it wants to do? Having split-phase power designed to integrate directly into North American wiring standards. Having dual AC inputs so you can have both grid and generator on one site. And also understanding that a successful installation is not just about the inverter itself. You have to have an integrated balance of load system so that it makes integration and installation of the system easy and simple to do successfully. The other thing that we realized is that solar is becoming a mainstream industry. Those people who, to be honest, geek out about technology, well, they've probably already purchased their system if they were going to do it. Now we're really looking at moving solar to those people who buy solar for the benefits, not for the hardware. They want to think about their solar electric power system just about as much as they think about their boiler or their hot water heater, which is, to be honest, they don't think about it. They just benefit from what it provides them, warmth and heat. Similarly, with the renewable energy system, with the power system, it provides them power and security and renewable energy. So in that theme, we designed the product to look like a power appliance. Stainless steel lid, powder-coated galvanized steel enclosure, clean, streamlined, designed to have a minimum amount of protuberances and fins. Again, it's not just about the inverter. You've got to make it easy to successfully install the system. So we've designed an integrated GSLC load center with reversible stainless steel hinge cover, dead front and side, that works directly with the inverter. We've also offer factory pre-wired options available for those who wish to have a streamlined way to install a system. But we at OutBack know, we have a lot of history knowing what it takes to actually run loads in a house and what it's like to work in the real world. And what you need is an efficient inverter with an extremely low tear loss and redundancy. The ability to have a field serviceability option, easily field serviced, is really critical, especially when the inverter provides the power that is the lights and the communication and the water for the home. Having some way to quickly service the system when the inevitable happens, be able to get the power back online as quickly as possible. We built the Radian series around two identical power modules. Each power module is 122/40 volt full output, 4,000 watt per block. Each block is built around the FET board that that the industry knows as the core of our FX, our legendary FX product. By having dual power modules, we get almost unheard of efficiency in terms of 30 watt tear loss for an 8,000 watt inverter. There's no inverter out there with a better tear to rated power ratio. It also allows us to have a nearly flat power curve, above 90% from low power all the way to full power output. And that makes a big difference whether you have a small system that might be operating in standalone operation where most of the time the loads are less than 1,000 watts, but then the system needs to be sized for large surges, for motor or pump starting, or in a grid interactive mode where you may be trying to sell back the full 8,000 watts throughout the day. Having high efficiency at both ends of the power curve, we're the first product that's been able to provide that. In a standalone application, surge is king. The inverter must be able to start the largest amount. It must be able to power the most that you throw at it at any one time. It doesn't operate in a constant state such as a grid interactive or a standard grid direct inverter. But it's also important not just to have a high surge number, but to have a good surge quality while providing that number. There are products out that allow a very high number, but at the sacrifice of quality. They allow the voltage to drop and dip precipitously. We don't believe that's acceptable. We believe that in today's world, with more and more sophisticated electronics, that voltage quality while providing surge capacity is really key. Now, for those who've known OutBack, you know that we've made a 120-volt modular inverter that was always combined up in series and in parallel to make larger systems. We were adamant that we did not and would not make a split-phase inverter for one simple reason. All split-phase inverters must lift the neutral or disconnect the neutral when synced to grid as part of their grid loss or grid detection anti-islanding circuitry. Now, an AC electrician will tell you that one of the most disastrous things that can happen to a home in North America is to lose the neutral through accident for any reason. When that happens, then there's uncontrolled voltage that can show up on either phase based upon what random loads happen to be turned on and on at that moment when the system loses its neutral. Up to 240 volts shows across either of the phases, and all the appliances on that phase just blow up. Now, all split-phase inverters, because they must disconnect the neutral while connected to or when synced to the grid, anytime they are reacting to the loss of grid, there's some period of time when they are in a reactionary mode, where they're reacting to the loss of power, and until they can detect and then fire their relays to bring the neutral back into play, there's the potential for up to 240 volts to show up across either phase. We at OutBack knew that, knew it was an Achilles heel of certain designs, and we were adamant that that was unacceptable. Our engineers knew that in order to successfully have a split-phase inverter, we had to lick that problem first. Well, we looked at it, came up with a method of detecting and, better yet, responding to that, being able to clamp down on that voltage and control it before it becomes a problem. Once we knew we had a solution to that problem, then we could go ahead and progress with releasing this inverter. But again, a good solution is not just about the hardware. It's about how easy is that system to use and how easy is it to set up as an installer to accurately set all the various parameters that are needed to successfully operate the system. And with the battery-based systems, it can be complex. There's a lot of different functions that all have to work and work seamlessly and work in coordination and not in opposition. We've always been known for an incredible amount of control and capability that we provide to the installer, but we know that that by itself can be a challenge because that complexity, well, it's it can be hard to get it all right, and sometimes people can program things, miss something in the programming, or even program something in opposition, select a mode that might conflict with another mode. So with the Mate 3 and the Radian series, we really wanted to simplify the process of being able to successfully set up the system. So we came up with a concept, not a new concept, but built-in a concept of configuration wizard with the Mate 3, where you just simply answer a few questions about what you have and what you want it to do. And then Mate 3 reaches out and programs all of the components in the system accurately and appropriately. Similarly, with the Radian, we invented a concept called input assignments, where while there are two inputs on the Radian, and one is labeled grid and one is generator, there's many different types of grid. There's grid where you are grid interactive and trying to sell back. There's grid where you're using the inverter as a UPS or a backup power supply. There's some grid where you might want to use the grid as a charging source, but to run independently and only reach out to the grid when you need it for charging the batteries if the solar can't keep up with the loads. Similarly with generators, there's good generators and there's crappy generators. The programming is different for each one, and if you don't get it right, then you can have, in the past, if you didn't get it right, you can have erratic performance. So for the Radian series, we just came up with concepts such as grid interactive, up mode for UPS style programmability, good generator and crappy generator. And when you make those selections, then we program all of the appropriate settings that are right for that requirement. Now you can go in and override those settings if there's something you want to do a little differently, or tweak it and tune it to your heart's content, but you don't have to. Similarly, both of these devices are the first products that we've had that are field upgradable. If there's an idea that you have, if there's something that we think of that an additional functionality that we like or believe that would be helpful for you, we can develop that and then release it as a new upgrade. You can download that from our website, or we can email it to you, copy it onto an SD card, and update the device. And that does not require you to have an external dongle, and it doesn't require you to have an external computer with its appropriate power supplies and other requirements. So especially as we look into the future, we're seeing more and more larger systems coming into play, and systems that really stretch the imagination of what we thought was possible. We at OutBack, our engineers have been part of some of the largest systems we believe on the planet. We have certainly more than our handful of 6 or 10 inverter systems. We've got 30 inverter, 36 inverter, 80 inverter systems out there. People have really pushed the boundaries of what can be done with energy storage and energy conversion. But what hasn't ever existed in the past was an easy way to do it. We have different sheet metal kits, as I mentioned, for larger systems, but then quickly things become custom, and custom's very challenging to do. It is not easy for an installer or integrator, and it's certainly not easy to do accurately or quickly. With the Radian, we came up with a concept called AC busing, where it'll, building upon the lessons that we've seen the grid direct market use as installers have moved up from 1 or 2 inverter residential installations to larger and larger installations, and when they're doing their first 50 or 100 kW grid direct system by using basically AC load centers as distribution load centers, and to use standard off-the-shelf componentry and standard wiring practices to scale up and do larger systems with known costing. We've approached and approach battery-based design in the same manner with the Radian series. So again, using lessons from larger grid direct installations where people have scaled up. If an installer begins as doing residential and maybe they're doing 4 kW systems. They know that every 4 kW inverter will take a breaker on this side, a couple strings and modules on that side, and assorted disconnects. The first time they do an 8 kW system, they can very easily multiply by 2. It'll take me 2 of these and then a couple of these, and quickly know their costs in terms of not only components to bring in the field, but even the amount of time it's going to take their crew on that job. Now, imagine if we could do that for battery-based systems. The supply side tap to a new solar distribution, follow up that thought a little bit more. The first time that installer gets a 50 or 100 kW system, then they can quickly scale up successfully. Now maybe they use a little larger inverter, 8 kW instead of 4 kW, but they can really quickly scale out their costs and figure 10 of these will take me that long, and be able to do an installation and design and quote accurately and successfully. So in a similar manner, doing a battery-based system, supply side tap to a new solar distribution panel, individual 50 amp 2-pole breakers feeding each inverter input. Then the output, now up to now, this is everything that an installer uses to scale out on a grid direct application. I'll basically duplicate this on the output side with the inverter outputs going to a second solar output panel. The feed from that solar output panel goes onto the house protected load panel. Now you have a battery-based system with input and output. Now, maintenance bypass, if desired, and I do think that this is a good idea. Well, in the past, we've done that with larger and larger groups of breakers and custom arrangements with kludgy metal slider plates. But to be honest, at this scale, we're well beyond what makes sense doing that. We're well beyond that limit, especially because double pole, double throw safety switches are available from a wide range of sources from 100 amp to up to thousands of amps in both manual and automatic versions. Why should we be reinventing that wheel when it's all available off the shelf? So diagrammatically, what that would look like is main load center, again, supply side tap feeding a solar distribution load center, which feeds each inverter input. Output of each inverter goes to a new output combiner, and the feed from that goes to a transfer switch external to the system, and the final power goes to the house protected loads. Now, this is a scalable solution that can be done with 2 to any number of inverters using standard off-the-shelf componentry with no special customized sheet metal, nothing unobtainium. This is how I believe the future of energy storage will be written. So let's take a quick look at the competition. Who do we see out there? Well, Schneider XW, good competition. They did an incredible job at looking at what the FX didn't do particularly well and really polished those sections. 6,000 watt, 120, 240 volt all in one box with the simplified design and streamlined control panel. Their power distribution panel gave you a one-line item to install a single inverter and a couple charge controllers pretty easily. They make a handy little second inverter kit. I always thought it was a little kludgy that you had to throw away half of the first inverter kit to make it work, but it does work. But really, when you want to go beyond that, as systems get larger, it's really not factory supported. They'll give you a length of wireless, but that's pretty much meaningless. Now, they have a handy way of plugging devices in for device communication that they call Shunt Bus. They has an advantage in doesn't require additional components. Now, our system requires a hub to allow the inverters to communicate for the different devices. They believe that SAN bus is an advantage. We don't have to buy an extra box. I disagree with that. The issue is the inverters don't just have to play nice with each other. They have to operate as a team. The FETs have to switch at the exact same time. And SAN bus architecture is really CAN bus. It's an addressing protocol that's designed, originated in the automotive industry. And it's not very fast, and it's not particularly robust. It's limited in the number of devices that it can support, and it's susceptible to noise and interference and signal degradation. In theory, with SAN bus, you have the ability to connect up to 6 devices. What they don't tell you is what counts as devices. Well, system control panel, just the ability to control the system, counts as a device. The charge controllers, generator start, all count as devices. External communications options all count against the device. But then as the device count gets larger, because it's the communication between the inverters is what's key, you can get to a point where you begin to have erratic performance across the inverters because they cannot communicate quickly enough. With the OutBack's hub infrastructure, there's direct, robust communication between each inverter, between the master and every slave, where they all act as a team and through all conditions. Now, this last bullet point about overseas manufacturer, this is not intended as China bashing. It's just a reality of a long supply chain. Anytime you manufacture products, well, my history from working in distribution with Xantrex was it was feast or famine. I either had more inverters than what I knew what to do with, or I was missing 1 or 2 small widgets, and those widgets would be out with lead times out a couple months. I might have everything that I needed in stock to be able to ship a large order except for 1 charge controller, but the solution on when that charge controller would arrive would be months out. We at OutBack, we've always been on Arlington, or manufactured in Arlington, Washington, and we're really committed to supplying our partners with product at the right time in a short lead time, and I think you'd all agree we've done pretty well with that in the past, and we're going to keep that up in the future. Now, SMA Sunny Island, a really, really brilliant product. Unfortunately, it's really best suited for the rest of the world. And AC coupled solutions have a lot of advantages in certain applications. Anytime your loads match the production cycle, you are going to see higher efficiency with an AC coupled solution. No doubt about it. However, that's not the real world for most people. Most standalone or off-grid applications, they do not have large daytime loads. They're mostly nighttime loads. And most of the world, or most of the U.S., is not on feed-in tariff. Maybe we should be, but we're not. So therefore, why pay for that efficiency? The other thing is SMA, no matter what, brilliant solution, but never known for being a particularly cost-effective solution. It's an expensive box. It's mostly expensive because you have to buy 3 times as many inverters as what the customer really needs. You have the Sunny Boys and the Sunny Islands, but the Sunny Boys are 240 and the Sunny Islands 120. So that means you either need 2 Sunny Islands to go with your 1 Sunny Boy, or you need an autoformer or a transformer. If you put a transformer, where does it go? Does it go on the output of the Sunny Island and becomes the choke point? Do you put it on the input from the Sunny Boys? Or what if, there's all kinds of design complexities that just make your head spin. The other issue, of course, is, to be honest, it's a great product, but it doesn't integrate well into the U.S. regulatory climate. Anybody who's worked with a persnickety inspector knows how challenging that can be. Just you get a nice 250 amp breaker in the middle of the device, but most inspectors won't allow that to stand as the service disconnect, so you put other ones upstream. Input terminals are designed for parallel cables, but the cable ampacity don't match the ampacity of the breaker. In fact, they don't fit the wire size of the conduit fitting that they put on the device. All kinds of challenging. Each one needs to be hammered out with your inspector, hopefully not after you've installed the system. So now, this quick competitive analysis chart, people love these things. To be honest, it's a bit of an eyesight test here with this many things, but let's suffice it to say green is good. We got a lot of green. All right. But the big question comes up from folks is, what about the FX? People know our FX. They've been using it for many years. They've baked it into a lot of solutions. They're very familiar with it. Well, we're here to say we view the Radian series as an expansion of the line. It's designed to supplement the FX, not replace it. The FX has a lot of strengths and certain applications where it will always be the preferred product. And we're going to continue to grow and support the FX line. If I had to get it down to a bullet point list of which inverter to choose where, what I'd say is the Radian series would be the preferred solution for any larger applications for home or business, any application where you need grid interactive with the ability to charge from a secondary source, anywhere where 120, 240, 60 hertz output is required, which is pretty much any home with shared neutral wiring, which is the majority of North American market. The FX will continue to be a strong solution for smaller systems, whether grid interactive or standalone. Anywhere where you've got dusty or coastal environments where the sealed, rugged sealed design is preferred. Three-phase power. Any international applications, and this also includes the odd voltages, both DC voltages. We make the FX in a lot of different flavors, not only different DC voltages, but also the odd international standards, the 110-50 hertz, things like that, that will still be, the go-to solution will be the FX. All right. Now, just a quick run through of the different model numbers and options available. Of course, there's the inverter itself, the GS8048 for grid interactive and standalone applications, 8,000 watts continuous, 120, 240 split phase power with dual AC inputs and field upgradable firmware for $59.95 MSRP. There's the GSLC, available both in pre-wired and fully customizable versions, designed to bolt directly up to the Radian and either eliminate or certainly reduce all custom wiring. Now, quick run through on the different variants there. There's a AC pre-wired, or doing, say, a generator-only system or a backup system. It's, again, designed so that totally pre-wired from the factory, available to ship, so that the installer can do all the installation with simple screwdriver and wrench terminations. All field connections land on bus bar terminations. Just basically strip the wire and plug it in and tighten it down. No crimps or ring terminals required. 1345, fully pre-wired out the door. There's also a fully pre-wired version that includes both array inputs, ground fault detection for 2 charge controllers, the dual AC inputs and bypass, FlexNet DC, 2 additional shunts for a total of 3, and all pre-wiring so that the only connections you need to make, including the array, land on simple bus bar terminations. But as OutBack, we know that there's a lot of people who don't fit into cookie-cutter solutions. They want the flexibility to design the system and wire it exactly how they like. For those customers, we've always made our FlexWare enclosures in an empty box that a customer would populate with breakers to exactly fit the needs of the application. Similarly, we'll make the GSLC available in an empty enclosure with all of the customized bus bars and shunts required to do the installation, and then you populate it as you see fit. For those customers, we make a bypass kit with a breaker, slider plates, bus bars, and terminated and label wire kit to quickly populate that. We have 2-pole AC breaker, a DC shunt bus to be able to connect 3 shunts in the GSLC, and short bus bar kits. It's important to note that the Radian series only programs with the Mate 3. The Mate will not recognize the new inverter. The Mate 3 has a lot of advantages over what you've been using in the past. A configuration wizard to quickly program the entire system after answering a few quick questions. The ability to get all of the information that you need about a given set point or parameter or operation mode by pressing one button instead of having to scroll through numerous menus. And the ability to update the firmware at any time in the field with a simple file update. There's a couple ways you can mount the Mate 3. There's a flush mount bracket that's designed to mount over a electrical box, single gang, double gang, triple gang, whatever you have, and it will mount over. And also the FlexWare MB3 mounting bracket designed to go off the side of the FlexWare enclosure also mounts off the side of the Radian series inverter. Here's a picture with the Mate 3 mounted on the side of the inverter with the FlexWare MB3, and you'll see the hub mounted slightly below that. There's also a second set of mounting options to be able to mount the, here, I'll put this, you can mount the hub here and then the Mate 3 mounted there so that no matter where the inverter is on the wall, you can get the display at eye level. So quick run through on the pricing, GS8048, $59.95. That comes out to 75 cents a watt MSRP. Similar price aimed directly at the XW, to be honest, and looking really pretty good against the Sunny Island. But it's important to really understand it's not the inverter by itself. It takes the full system to make a power solution. So for a simple AC-only system, with the factory doing all the pre-wiring, GS8048, pre-wired enclosure, Mate 3 and mounting bracket, you can be out the door for $1 a watt MSRP. 5-cent delta over the XW, but most systems are probably going to add some array. That takes a few more components, add a couple charge controllers and a hub for the XW. Similarly, and $1.28 MSRP for an OutBack system, and $1.30 for the XW, and looking really good against the Sunny Island. Now, most systems of this size, they're probably going to have backup for a generator. For our system, that's included. No additional components need be applied. For the XW, they require an automatic generator start module that adds another $200 to the cost of their system. For Sunny Island, not even sure how they manage that one. So, but to summarize, Radian series really designed to make it easier throughout the channel to make a successful implementation of backup and grid interactive and standalone power systems. You really simplify the lives of all of us and make it easier to make a successful solution. Now, OutBack Power, building upon our reputation and our history as being the go-to power providers in the market. So that's it. I appreciate your time and patience today. If you have any questions, then please ask your sales rep or visit our website at www.outbackpower.com. And thank you very much. Have a good day.